So today what we are going to do is formation of differential equation from its solution, which means, what does that mean? Solution is given to you. Solution is given. You have to find what is the differential equation. Yesterday I taught you this. How to solve this differential equation. Did I teach you this?
Yes.
Yeah. Solving the differential equation means making y as a subject or finding what is y. What did I do? I integrated once, it became dy by dx. And I got a constant. I integrated once more, dy by dx became y, and this became x cubed by 6, c1x, and one more c2 came in. So there became two arbitrary constants. So we have seen, if the order of the differential equation is 2, there will be two arbitrary constants in the solution. So first and foremost thing what you should do is find how many arbitrary constants are there in the solution. So when a differential solution is given to you, find out how many arbitrary constants are there, which means suppose there are 3 arbitrary constants, which means your differential equation is of order 3. Is that clear? Now next point. To solve the differential equation you integrated. From the solution, if you want to go back, what should I do? From the differential equation to get the solution, we did integration. From the solution, if you want to go back to the differential equation, what should I do? Tell me.
Differentiation.
Differentiate. Now the question asked, how many times to differentiate? I know only the solution. How will I come to know how many times? This is a solution of what order differential equation? There are 2 arbitrary constants, hence it is a second order differential equation. So if there are only 2 arbitrary constants, you got to differentiate twice. Is that clear?
Yes.
Yes. So once again, I'm going to tell you, once again, I'm explaining to you. If I am given a differential equation, how to find the solution, how to find y, you got to integrate. If we are given a solution, how to find the differential equation, you got to differentiate. How many times should I differentiate? How many times should I differentiate? How will I come to know that? You got to find out how many arbitrary constants are there in the solution. Then differentiate as many times. Suppose there are 3 arbitrary constants, you got to differentiate y 3 times. Is that clear? Not only that enough, that is not enough. After differentiating, the differential equation should not contain arbitrary constant. Shouldn't contain arbitrary constant. Did you follow that? So what is the method of formation of differential equation? Just tell me once again. What is the method? Method to formulate a differential equation. From its solution. Step 1. Calculate number of arbitrary constants in the solution. Step number 2. Differentiate the solution. How many times to differentiate? Number of times to be differentiated is equal to number of arbitrary constants. Number of times to be differentiated is equal to number of arbitrary constants. Step number 3. Also remove the arbitrary constants and formulate the differential equation. So let's take an example. I'm going to take it into first type of question, type 1. Solutions with one arbitrary constant. Solutions with one arbitrary constant. Okay. Now I'll give an example. Y equal to mx plus root 1 plus m square, where m is the arbitrary constant. Tell me how many arbitrary constants are there in it? How many arbitrary constants are there?
One.
One or two?
One.
One. M is only once. So only m arbitrary constant. M stands for slope actually. So if this is slope, then this also is slope. So there's only one arbitrary constant. If there is only one arbitrary constant, how many times should I differentiate? So I can
One.
make a conclusion. This is solution of first order differential equation. Do you agree with the statement? If it's a solution of first order, I'm allowed to differentiate only once. If I differentiate only once, I'll get dy by dx is equal to m. There is derivative of m into derivative of x. All these are constant. Now what I'll do, I need an equation without m present in it. How will I form an equation without m present in it? Wherever you see m, all the m I'll replace by dy by dx. So substituting 2 in 1. So y is equal to x into dy by dx plus root of 1 plus dy by dx the whole square. Usually we don't keep square root, radical powers are not allowed. So y minus x into dy by dx, the whole square, equal to 1 plus dy by dx the whole square. Now if you feel like you can expand it, or you may leave this is a required differential equation. I want you to understand the logic behind it. First point is, there is only one arbitrary constant. That means there is only one integral constant. That means you are integrated only once to get this answer, which means the differential equation is of order first order. If the differential equation is of first order, you are allowed to differentiate the solution only once. And also, you got to eliminate m. And what is the technique I use for eliminating m? I made m as a subject and substituted in it. Is that clear to everybody?
Yes, sir.
So whenever we have only one arbitrary constant, this is a technique to apply. Differentiate once, make the arbitrary constant subject and substitute in the solution. So what is it? What are the steps I told you? How many times differentiate? Differentiate only once. Then make arbitrary constant as a subject. Then what should I do? Third step, after making this as a subject, what should I do? Substitute in the solution so that the arbitrary constant is removed. Is that clear to everybody? Yes or no? Come on, respond, students. If you are going to keep keeping your mouth shut, then I'll feel so difficult to teach. I told you this. Okay, let me see how many of you can do next problem. So I'm taking one problem from your textbook with one arbitrary constant. So that is the first question. X cube plus y cube is equal to 4ax What is this? Is a solution of a differential equation. Formulate the differential equation. Whose solution is x cube. It is cube, both are cube. X cube plus y cube is equal to 4ax. This is a question. Tell me what is the first step I should do. How many arbitrary constants are there?
1.
1. So how many times I'm allowed to differentiate?
One.
Once. After differentiating, what should I do? Make A as a subject
and then substitute.
and substitute back. Very good. So let's start. All of you start with me. Differentiate with respect to x. Write your answer. Derivative of x cube, 3x square. Derivative of y cube, 3y square into derivative of y, 4a into derivative of x. That means you got already 4a. You don't need a. You can directly replace 4a. So call this a equation 1, equation 2. Substituting 2 in 1. What will you get the answer? The required differential equation is x cube plus y cube is equal to, instead of 4a, what should I write? 3x square plus 3y square dy by dx. This is 4a. 4a into x. So I put an x here. So x cube plus y cube is 3x cube plus 3xy square dy by dx. Now one x cube you can cancel off and make it 2. So my final answer is 3xy square dy by dx plus 2x cube minus y cube equal to 0 is your final answer. Have you understood or not understood?
Understood. Yes.
Everybody clear?
Yes, sir.
Yeah, this is exercise number 6.2. First exercise 6.1 was how to find order and degree, that which we did yesterday. So exercise 6.2 is formulate the differential equation when solution is given to you. So I'm just giving you the first problem. Can I do the next one?
Yes, sir.
Okay. This requires a little thinking. That is a third question in your book. Y square, not third, fourth question. Okay, you don't worry about that. Y square is equal to x plus c the whole cube. So how will we go about this?
1.
Yes, tell me. You said something. Mandara must have got disconnected. If I differentiate this, what will happen?
We will get like 3x
Yeah.
plus 3.
The only one arbitrary constant. Just look at my both methods. One arbitrary constant, two methods I'm going to teach you. If it is only one arbitrary constant, I allow to differentiate only once. So I'm going to differentiate once. 2y dy by dx is equal to 3 into x plus c the whole square into derivative of x plus c, that will become 1. Is this derivative clear?
Yes, sir.
I am supposed to eliminate the c, but making the c as a subject, square root, divide, it becomes difficult. So what I'm going to do, one option I have is, I will take this as 2y dy by dx upon 3. The whole raised to 1 by 2 is x plus c. Chalega? Now this I can replace in this. So substituting 2 in 1, what I'll get? Y square is equal to 2y dy by dx upon 3 raised to 3 by 2. Any doubt? Instead of this x plus c, what did I write? This whole thing, that's how 3 by 2 has come. Now we are not supposed to keep any radical power. So what should I do next step? Square both the side. Y raised to 4 is 2y dy by dx upon 3, the whole cube. Now this became 27, this became 8. So 27 will get multiplied. 27 y raised to 4 is 8 y cube dy by dx the whole cube. 1 y cube get cancelled. So y is 8 upon 27 dy by dx the whole cube. This becomes your answer. You can make it equal to 0, or you can do like this. No need of writing this way. You can write 8 dy by dx the whole cube minus 27y equal to 0. This way also you can write it. Now,
Sir,
second method.
sir,
Ah,
one doubt.
yes, sir.
Sir, where did that y square come from in substitute 2 into 1?
Where this square has come.
Yes, sir.
When you differentiate x plus c the whole cube, what is the derivative?
3x plus c whole raised to 2
x plus
into
c the whole
derivative
square into derivative of x plus c.
x plus c.
Derivative of x plus c is 1. तो आपको इतना ही आएगा डेरिवेटिव. ये समझ में आया?
Yes, sir.
फिर एक्चुअली मुझे c सब्जेक्ट बनाना चाहिए, लेकिन मैं c के जगह x plus c को सब्जेक्ट कर दिया. चलेगा? तो क्या हो जाएगा? a3 नीचे आएगा और स्क्वायर रूट निकालने के लिए स्क्वायर निकालने के लिए रेज टू 1/2 आ जाएगा. समझा कि नहीं?
Yes, sir.
Yes. Now see my next method. Y square is equal to x plus c the whole cube. Fine. आप बंद करो ना. Okay. Now make x plus c as a subject. Look at this. चलेगा? Now इसको differentiate करो. क्या आंसर आएगा? 2/3 y raised to minus 1/3 into dy by dx equal to 1. Automatically क्या हो गया? C उड़ गया. So I got directly the equation. I don't have to eliminate C. C अपने आप उड़ गया. So 2y raised to minus 1/3 into dy by dx equal to 3. लेकिन नेगेटिव पावर अलाउड नहीं है. So 2 dy by dx a इस तरफ आएगा तो 3y raised to 1/3. समझ में आया? रेडिकल पावर अलाउड नहीं है, तो उसको क्यूब किया. इसको क्यूब किया तो इनके 8 dy by dx the whole cube is minus 27y equal to 0. वही आंसर आ गया. देखो प्रीवियस आंसर यही था ना. Same answer I have got. Have you followed this? So you can do two ways. What I want to explain to you in this problem is I can do two ways. One method is after finding the first derivative, make either c or x plus c as subject and substitute. Second method is make c independent of x. मैंने क्या किया इधर? मैंने क्या किया जरा देखो. By taking the cube मैंने क्या किया? c के साथ x है ही नहीं. If I differentiate anything without a only constant alone, वो 0 बन जाएगा और मेरा आंसर में c नहीं होगा. Ultimately, I didn't want the c to be present in the answer. Am I right? Have you understood this idea?
Yes, sir.
Idea roots the world. आपको idea लगाना है कैसे c को निकालना. So one method I taught you, make it a subject, differentiate once, make it a subject and substitute. दूसरा method मैंने क्या आपको सिखाया अभी? c को अकेला कर दो. c के साथ कोई x term नहीं है, y term नहीं है. Then you differentiate. Automatically c will go away and you get answer directly. Did you understand this technique?
Yes, sir. Yes, sir.
Let me see one more question is there. But I'm taking all questions with one arbitrary constant. Okay?
सर सब में ये यूज कर सकते हैं.
सब में नहीं, जहां पे आपको देखना पड़ेगा. जैसे a क्वेश्चन y is equal to a plus a by x. आप कुछ भी करो, a को अकेला नहीं बन सकता है. a के साथ हमेशा a is arbitrary constant. a के साथ हमेशा x होगा. राइट और रॉन्ग? एलसीएम लिया, क्रॉस मल्टीप्लाई किया, कुछ भी करो, हमेशा a के साथ x होगा. तो टू मेक दिस आर्बिट्रेरी कांस्टेंट अकेला इट्स अ डिफिकल्ट टास्क. ऑफ कोर्स यू कैन डू इट. ऐसा नहीं कि नहीं हो सकता है, हो सकता है, लेकिन देन डेरिवेटिव विल बिकम लिटिल डिफिकल्ट. ऐसा हो जाएगा. एक अभी इसको डेरिवेटिव करेगा तो आपका आंसर आ जाएगा, ऐसा नहीं कि नहीं आएगा. बट इन दिस प्रॉब्लम इट इज बेटर टू डू फर्स्ट मेथड Did you understand? Because this derivative may become a little difficult. But you can do this method also. So मेरा method क्या है इसमें? There is one arbitrary constant. So differentiate once. Once you differentiate once, what will become? dy by dx, derivative of a. I'm writing this little step. A को बाहर निकाल दिया. Derivative of 1 by x. 1 by x को x raised to minus 1. So dy by dx is equal to 0 plus a into minus 1 x raised to minus 2. So dy by dx is equal to minus a upon x square. अभी a को सब्जेक्ट बनाने एकदम इजी हो गया, तो मैंने a को सब्जेक्ट बना दिया. Now substituting 2 in 1, y is equal to minus x square dy by dx plus minus x square dy by dx divided by x. So y is equal to minus x square dy by dx minus x dy by dx. बराबर है कि नहीं? Is it clear? Now make it equal to 0. X square आपको dy by dx कॉमन ले सकते हैं, plus y equal to 0 is the required differential equation. चाहे तो x भी कॉमन ले सकते हैं. Have you understood this?
Yes, sir.
So you have an option here. A को सब्जेक्ट बना के डेरिवेटिव करो, या तो डिफरेंशिएट एंड a को सब्जेक्ट बना के सब्स्टिट्यूट करो. दोनों मेथड आपको बराबर होगा. Is it clear? Whichever you feel like you can do it. I think you have understood. All of you understood.
Yes,
One
sir.
arbitrary constant. Now comes the real one. So type number 2. Solutions with two arbitrary constant. Now the technique of this varies according to the question. So I will write in this type 2 में solutions of the following form. One, y equal to a cos nx plus b sin nx. Y is equal to a sin nx plus b. Third, y is equal to a cos nx plus b. Fourth, y is equal to a e raised to nx plus b e raised to minus nx. Remember, n is a real number. A and b are the arbitrary constants. That means in the exam they will be giving you y equal to a cos 2x plus b sin 2x. A number will be there in place of n. N can be any number. So it will not be an arbitrary constant. Only a and b will be arbitrary constant. Is that clear to you? Actually,
Yes.
this you have learned in your 11th, your physics. This is called SHMs. We learned SHM, simple harmonic motion. Anybody? Simple harmonic motion पढ़ा है कि नहीं पढ़ा है?
पढ़ा है.
Can anybody tell me the definition of a simple harmonic motion? When do you say a particular motion is a simple harmonic motion? ऐसा मत पूछो कि मैंने उससे फिजिक्स पढ़ाना शुरू किया. नहीं, फिजिक्स मुझे मालूम ही नहीं है, but उतना तो मालूम है because it comes in maths. Previously, this topic was a maths topic. So tell me, what is when do you say a particular motion is a simple harmonic motion?
So a periodic to and fro motion.
That is your logical method. Mathematical way, the acceleration should be proportional to the displacement, and it should be opposite to the displacement. So d square x by dt square is equal to minus omega square x. This is the differential equation of a simple harmonic motion. And the solution of this is x equal to a sin omega t plus alpha. याद है कि नहीं? Right now, This all are solution of a SHM, all three of them. Are you followed? This is not a solution of SHM. This is not a solution of SHM. These three are same solution because you know that a sin theta plus cos theta can be made sin theta plus alpha. वो तो मैथ्स में मैं आपको पढ़ाया है. Just I'll remind you. If I give you a sin x plus b cos x, I can write this as root of a square plus b square into sine of x plus alpha. याद है कि नहीं है? याद है कि नहीं है?
Yes, sir.
Yeah, sir.
Yes.
Sir.
Where alpha is tan inverse b by a. ऐसा मैंने पढ़ा है ना? So if you look at this question can be converted to this, and sine of an angle can be converted to cos. Sine theta is cos 90 minus theta. So this all three are the same format of a same solution. That means your answer for all three is going to be same. And that is exactly the format of a simple harmonic motion. Is it clear to you? Yes or no?
Yes, sir.
Yes,
So
sir.
if I give you like this, y is equal to 2 sine omega t plus 2 cos omega t. If I give you y is equal to 2 sine omega t plus alpha, all of them are SHM solution of a, it's a how actually it is x. This is x. This is a displacement. This is a time. It's a relationship between displacement and time of a simple harmonic motion. Is it okay? Now let me come to what I have to teach you. What I am supposed to teach you, I am supposed to formulate the differential equation. What is the method of formulating the differential equation? What is the method to formulate the differential equation? Tell me the method. First step. What is the first step? The first step. Where? What is the first step? Or not this. General method I have given you. Step number 1, calculate the number of arbitrary constant. Step number 2, differentiate. Number of times to be differentiated is equal to number of arbitrary constant. Have you written all this?
Yes,
Yes.
sir.
And also remove the arbitrary constant by eliminating the, after that what you have to do? Eliminate the arbitrary constant and formulate the differential equation, right? So what are the steps in this problem? Tell me. What are the steps in this problem? I have to ask you what. First step, calculate how many arbitrary constants are there. How many arbitrary constants are there?
2.
2, A and B. Why don't you take n as arbitrary constant? Because in your question, n will be a number. Although I have put a n here, it will be 2, 3, 4, like that numbers will be instead of n. So there are 2 arbitrary constants. If there are 2 arbitrary constants, how many times I'm allowed to differentiate?
2.
2 times. So I'll be differentiating 2 times. After differentiating 2 times, I must remove A and B and formulate the equation. Is it clear? So my first 2 part remains same for all problems. Let's have a look at this. Y is equal to 3, okay, A sine 3x plus B cos 3x. This is a solution. Formulate the differential equation. 2 arbitrary constant allowed to differentiate twice. A into derivative of sine 3x plus B into derivative of cos 3x. A into cos 3x into 3. B into minus sine 3x into 3. If I take 3 common, A cos 3x plus minus B sine 3x. Again differentiate. I allowed to differentiate twice. D square by dx square is 3 into A into, what is the derivative of cos 3x? Minus sine 3x into 3. What is the derivative of sine 3x? Cos 3x into 3. I cut down the steps because you have repeated the same thing you have to repeat. Minus 9 became common. A sine 3x plus B cos 3x. So I have differentiated twice. But that is not enough. My answer should not contain A and B. So how will I remove this A and B?
Substitute as 1.
Yes, that is nothing but y itself. This what you see here and what you see here are same stuff. So I can replace this by y. So the differential equation is d square y by dx square plus 9y equal to 0. Do you understand? So
Yes,
I
sir.
can say all of them will work in the same manner. All of them, I mean, which are the all of them? This. All of them will work in the same manner. What I should do? First, differentiate twice. So I'm writing the method here. Method. Oh. Differentiate twice. Then eliminate a and b by substituting y. That's all to remember. Is it clear to everybody?
Yes, sir.
Have you written this?
Yes.
Okay. Now let's start with the problem. Write the first question. Formulate the differential equation whose solution is y is equal to a e raised to 5x plus b e raised to minus 5x. So there are two arbitrary constants. It is of this format. Look at this. This of this format. Instead of n, it is 5. Here is minus 5x. They are only change in the negative sign. So whenever you come across such type of problem, differentiate twice. So differentiate with respect to x. So dy by dx, at least one derivative you show the whole step. Another derivative onwards, you may do directly. They should know that you know how to differentiate correctly. One step only you show all this. So it became a into e raised to 5x into 5 plus b e raised to minus 5x into minus 5. If you take 5 common, a e raised to 5x minus b e raised to minus 5x. Now again you differentiate. D square y by dx square 5 into a into d by dx of e raised to 5x minus b into d by dx of e raised to minus 5x. So my answer will be d square y by dx square is a into, 5 into a e raised to 5x into 5 minus b e raised to minus 5x into minus 5. So this d2y by dx2, take another 5 common. So a e raised to 5x plus b e raised to minus 5x. So your solution became, now you have to eliminate. So this is your equation 1. So substituting 1 in RHS. You will get these 2y by dx2 is 25y. So the solution is d2y by dx2 minus 25y equals 0. Is it clear?
Yes.
So I can say this much. Have you finished writing or still writing? Okay, can I change the page?
Yes.
Okay, look at this. Can you tell me the answer directly for this 2? The answer for this 3 will be d2y by dx2 equal to minus n square y. Answer for this will be d2y by dx2 equal to n square y. Only a minus, because sign when you differentiate cos, there will be a minus. Again, you differentiate, that minus will stay back. So all 3 of them, this will be your answer. And this question, this will be your answer. whatever the number here, that will be squared, and negative for sine and cos, and this one will be no negative. This will be answer. So in MCQ, you can directly write the answer without solving it. Is it clear? But your teachers are, in your board exam, the teachers are very smart. They may not give you like this direct question. They'll give you like this. Y equal to A cos of log x plus B sine of log x. This is March 2014. They asked this question. So it is of almost same format, but not exactly the same format. So your answer is not going to be d square y by dx square minus n square y. That's not going to happen. But the way you did the previous problem, same method can be adopted to eliminate A and B. Do you agree with this, what I spoke to just now? Okay. All of you start with me. Differentiate once. Only once. Don't differentiate second time till I tell you. So dy by dx is equal to A into derivative of cos log x plus B into derivative of sine log x. So what will be your answer? Minus A sine of log x into derivative of log x plus B cos of log x into derivative of log x. Is that clear? And now see my next step. Take the 1 by x common. With this x present over here, this will not come back to y. So cross multiply this x with the left hand side. So x into dy by dx is equal to minus A sine of log x plus B cos of log x. What is wrong if I would have differentiated this step? Either I will have to apply product rule or I have to apply division rule, right? And if I do so, I will not come back to y. But if I differentiate now, this will come back to y. So I can eliminate A and B. Did you understand?
Yes, sir.
Any problem? I didn't get.
No, sir.
Sridhar, I'm not able to get what you're speaking. Is this okay with everybody? Yeah, I got a chat. Let me see. No. Okay. Anybody, any doubt? Okay. Now tell me, how will I differentiate this one again? Now I'm going to differentiate again. When I differentiate this again, I don't think I have enough space, so I'll change the page. Derivative of x dy by dx is equal to d by dx of minus a. Okay. Oh. Where's that problem? Oh. No, not this. Yeah.
Sine log x.
Yes. Minus a sine log x plus b cos log x. So here I'll have to apply product rule. So when you apply the product rule, x into the second derivative of dy by dx, so d2y by dx2, plus dy by dx into derivative of x, minus a derivative of sine log x cos log x into derivative of log x, plus b into derivative of cos log x minus sine of log x into derivative of log x. I did it directly. Yeah? So x into d2y by dx2 plus dy by dx, I'll take minus 1 by x common, a cos log x plus b sine log x. And what is this? What is this?
Y.
It is nothing but y. So I can substitute this by 1. What is, let me show you the 1. This is equation 1. Call it as equation 1. Now substituting 1 in RHS. Substituting 1 in RHS. What this become? X into d2y by dx2 plus dy by dx equal to minus 1 by x into y. We don't have the habit of keeping anything in denominator, so cross multiply. That is x square d2y by dx2 plus x dy by dx plus y equal to 0 is the required differential equation. Is this clear? Have you understood or not?
Yes, sir.
Yeah. Now I want to teach you one more of the similar kind. So what is actually we did in this type of problem? In this problem, directly we came back to y because derivative of the angle part was 3. Whereas in this one, derivative of the angle part became 1 by x. So what we did, we took that common and cross multiplied so that second derivative will not create a problem for you. Let me see what are you going to do for the next one. Okay, write this question. Y is equal to e raised to minus 2x into a cos x plus b sin x. Can anybody tell me what I should do here? If I differentiate directly, will I come back to y 2 times if I differentiate?
Take e raised to 2x on left.
Take this unwanted term to the left hand side. So e raised to 2xy. Do you agree with what I have written? What is the meaning of e raised to minus 2x? 1 upon e raised to 2x. So 1 upon e raised to 2x I cross multiplied. A cos x plus b sin x. I want you to do this problem yourself. So please, this is your equation 1. Now differentiate with respect to x. E raised to d by dx of e raised to 2x into y is d by dx of a cos x plus b sin x. So apply product rule, e raised to 2x into derivative of y into derivative of e raised to 2x, e raised to 2x into derivative of 2x, a into minus sin x plus b into cos x. E raised to 2x common, dy by dx minus 2 plus 2y is minus a sin x plus b cos x. Now we'll find the next derivative. We'll find the next derivative. So differentiating with respect to x. So d by dx of e raised to 2x into dy by dx plus 2y is d by dx of minus a sin x plus b cos x. So I'll get the product rule again, e raised to 2x into derivative of this. When you differentiate dy by dx, it becomes second derivative. When you differentiate y, it becomes 2 dy by dx. Plus, now this as it is, dy by dx plus 2y. When you differentiate e raised to 2x, it is e raised to 2x into 2 is equal to derivative of minus a sin x minus a cos x minus b sin x. So much is clear. In the right hand side, left hand side, e raised to 2x is common. So I'm going to take e raised to 2x common. Inside the bracket, d2y by dx2, 2 dy by dx. Again, 2 dy by dx. This 2 and this 2 dy by dx will multiply. This 2 and this 2 will multiply. So 4y equal to, I'll take a minus common, a cos x plus b sin x. And that is nothing but your equation number 1. So e raised to 2x d2y by dx2 4 dy by dx plus 4y equal to minus e raised to 2x into y. E raised to 2x will get cancelled. So your final answer is d2y by dx2 plus 4 dy by dx plus 5y equal to 0 is your required differential equation. Is it clear? Are you followed? Say yes or no.
Yes.
Yes, sir.
This is one of the most important questions. If you are feeling difficult to talk over the, you can also chat with me, can send the message. Both the questions, last two questions are very important questions. They do ask in the exam. Now I'm going to teach you the last kind of problem in this
Sir.
category. That type. Yes, yes.
Sir, how did minus e raised to 2x came?
Minus e raised to 2x. In which step?
Second last step.
हाँ, ये क्या है? A cos x plus b sin x क्या है? E raised to 2xy है ना?
Yes, sir.
माइनस तो पहले ही था, तो माइनस ही रहेगा, और इसके जगह e raised to 2xy.
Yes,
I
sir.
can say substituting one. Substituting. Always वही करना है ना. अपने को लास्ट में a और b को कैसे निकालना है? We have to substitute the original function back. लेकिन इसको नहीं हो सकता है, इधर से हो सकता है.
Okay, sir.
Okay, done.
Yes, sir.
Now next type. Solutions of the form. Y equal to a e raised to nx plus b e raised to mx. What is the difference between the previous and this? There it was 5 here and here it was minus 5. But in this problem, both n and m are different. This problem is very important for you next year when you are going to solve second order differential equations. You are in 11th and 12th standard, we are learning only how to solve first order differential equation. For solving the second order differential equation, we need this formula. Okay, anyhow, let me start. As usual, I will do first derivative. Y is equal to a e raised to nx plus b e raised to mx. I'm going to derive a formula for you from this. Differentiate once. Y is equal to a into derivative of e raised to nx. E raised to nx into n. B e raised to mx into m. No problem, no? That gives you dy by dx. On left hand side, I have written only y. That gives you dy by dx. Again, differentiate once more. How many times I'm allowed to differentiate?
2.
With respect to x. So the second derivative d2y by dx2. A and n I took it. Now derivative of e raised to nx. E raised to nx into n. B m. Derivative of e raised to mx. E raised to mx into m. I hope you have no problem in the derivative. I have cut down the steps. So I can write n square a e raised to nx. M square b e raised to mx. This is my equation number 2. This is my equation number 3. Now comes the question of how do we eliminate this a and b? You don't come back to y like last time. What is the technique that I'm going to use to eliminate A and B? For that, I need to make you go back to the chapter determinants. You know that now straight line also I learned this again. This one linear equation. This another linear equation. This is a third linear equation. Each linear equation represents a line. If all the three lines are passing through one point, what do you say? The lines are? The lines are? Concurrent. The lines are concurrent. What do you say about the three equation?
Determinant is 0.
That is of course. The three equations are consistent. And the condition for consistency is the determinant should be 0. A1, B1, C1, A2, B2, C2, and A3, B3, C3. This determinant should be 0. That means X and Y will have a common value in all the three equations. X and Y will have a common value in all the three equations if this determinant is 0. Do you agree with this statement? Yes or no? Shagun,
Yes, sir.
आजकल तुम बातें नहीं करता है. Shagun, Ashley, why you people don't speak? Without you people speaking, I cannot teach. Okay. What did I say just now? X and Y have a common value in all the three equations, so the determinant is 0. Here, A and B have a common value in all the three equations. Because A and B is having a common value in all the three equations, the determinant of equation 1, 2, and 3 should be 0. Did you hear me properly?
Yes, sir.
Take correct of the problem.
Yes, sir.
In this linear equation, X and Y have a common value, so determinant is 0. In the determinant, is X and Y present? No, only coefficients are present. So now you tell me, A and B are having a common value. So A and B will not be present in my determinant. Only the coefficients will be present, which means the Y will be there. That is, your C1 is Y. You know that if I interchange the columns, no problem. A will not be there. E raised to nx will be there. B will not be there. E raised to mx will be there. Dy by dx, second equation, dy by dx will be there. N e raised to nx, m e raised to mx. Second derivative, third equation, n square e raised to nx, m square e raised to mx. All of you agree with this? If I expand this, what I answer I get is my required differential equation. Do you agree with the statement?
Yes.
What did I say last? On expanding this determinant, whatever the answer that I'm going to get will be my required answer. Understood what logic I've applied in this? Entirely different logic. What is the logic I applied? Equation 1, 2, and 3 are consistent in A and B. All of them have same values for A and B. Therefore, the determinant of these three equations should be 0. Now I'll use some property of determinant. The first property of determinant is I can take common. What are the terms which are common? E raised to nx is common. E raised to mx is common. So this became y1, 1. dy by dx n m. d square y by dx square n square m square equal to 0. Do you agree with the statement?
Yes.
This cannot be 0, so it will get removed. Now I have the equation as y1, 1 dy by dx n m d square y by dx square n square m square equal to 0. So I'm going to expand now. When I expand, y into nm square minus n square m minus 1 into m square dy by dx minus m d2y by dx2 plus 1 into n square dy by dx and n d2y by dx2. This should be 0. Now let me arrange in order. second order derivative. So m minus n into the second order. Now dy by dx, this and this minus m square. So let me take common m square minus n square dy by dx. Check whether you are understanding. Check whether you are understanding. This m square had a negative sign. This n square had a positive sign, but I took a minus common. Then the constant term. What is common here? Nm into m minus n into dy equal to 0. What is the benefit of me writing this way? M minus n is a common term in every statement. Inside the bracket, m plus n plus mny equal to 0 is your differential equation. This cannot be 0 because m and n are two different numbers. If they are same number, you are not allowed to apply this. So therefore, they cannot be 0. So this is your required differential equation. What is the differential equation? D square by dx square minus sum of the coefficient into dy by dx plus product of the coefficient into y equal to 0. You can mug up this answer for MCQ. So give me the answer for this. Y is equal to a e raised to 2x, b e raised to 3x. Give me the answer for what is the differential equation? Whose solution is this? This is a solution of which differential equation? Tell me the answer.
D square y upon dx square minus
Now
5
add both.
dy by
2 plus 3, 5. 5 dy by dx plus multiply both of them, 6y equal to 0 is your answer. So in MCQ, this is the most common MCQ in MHCT. This comes in MHCT directly. So you can just look at this number and write the answer. But in the board exam, you will have to do a whole thing. This whole explanation you have to do. Have you written or you want to?
Yes, sir.
All of you are written.
No, sir.
This determinant part you have written. What is the statement you wrote for determinant?
Not written, sir.
Not written. So right. Yeah, derivative here.
Yes, sir. Till equation 3.
After, then you have to write equation 1, 2, and 3 are consistent in A and B. Therefore, the determinant of that equation is 0. Board exam में directly this much you can write. You don't have to write this common etc. Of course, जो common term है उसको delete करना है. This is common. This is common. This is common. उसको मत लिखो. 1 n square. b raised to mx common. उसको मत लिखो. You will write 1 m square. So directly you can write this. This is just explanation. I wanted to write everything. But in the board exam, you need to write only this determinant. After that, expand the determinant. We'll get the answer. Yeah. So this is the final answer after this here. So I'm going to do something for the mic, If you are not responding, I feel very difficult to teach.